Last two times we talked about proportion versus a mean and how to calculate the margin of error. This time we're going to put it together and we're going to look at the confidence interval for a proportion or a percentage and look at how to do that in the calculator also. So let's start by going back to that same problem we looked at in the last one. We survey 100 people and 30 of them say yes. Doesn't really matter what the question is. It's not going to change the process. We want a 90% confidence interval for the percent of the population that would say yes. Start by finding P. P is the proportion of the population of the sample that said yes, and that's 30 out of 100. So 30 out of 100, don't need a calculator to do that. Sometimes you will, but not for something as easy as this. That's going to be 0.3. And then our margin of error is going to be the z-score associated with 90%, or 1.64, times the square root of p times q, which is just 1 minus p, right? The percentage that would not say yes, so 0.7, and that all divided by n. Okay, that will give us our margin of error. It's going to be, do 0.3 times 0.7 divided by 100. That gives us that, and then we can do the square root of 0.0021. That gives us 0.05 whatever. Multiply that by our 1.64. Right, so we get our margin of error is 0.075. And then to find the interval itself, we just start with p, right? So 0.3 minus 0.075, and that gives us 0.225. And then we do 0.3 plus 0.075. So 0.375. So anywhere between 22.5% to 37.5% of the population, we believe, with 95% confidence, fall into the category of people who would say yes. Now, to do that in the calculator, we would go to Stat, over to Test, and then down to one prop z interval. So one proportion z interval. Remember, we don't ever use a t interval for this. We don't need to. So we select that, and the only information we need to give it is the number of successes here, so 30, out of the number in the sample, which was 100, and it's already at 0.9 for 90%. Hit enter, and it gives us our 22.5% to 37.5%. All right, only three numbers you need to put in. Number that said yes, number in the sample, and the percent confidence, or the confidence level we need. Okay, let's look at another one. Suppose we examined 40 eggs, and 4 of them had double yolks. Used to happen a lot more when I was a kid than it does today. Find the 95% confidence interval. Okay, so we start by finding P. That's going to be the number of successes out of the total number. So in this case, it's going to be 0.1, which means that Q, of course, will be 1 minus that, or 0.9. Our margin of error is going to be 1.96, our magic number that goes along with the 95% confidence level, times the square root of 0.1 times 0.9 divided by the number in the sample. Okay. Little calculator work for that. 0.1 times 0.9 divided by 40 gives us 0.00225. Take the square root of 0.00225, and we get about 4.7% for our margin of error there. Oh, sorry, I didn't multiply by 1.96. So our margin of error is about 0.093. Start with our P, our proportion. 0.1 plus 0.093 will be, that'll give us our top number, 0.193. And if we subtract 0.1 minus 0.093, we'll get 0.007. So that's 0.7% to 19.3%. Let's use the calculator. Stat, over to test, down to 1 prop z int. We had 4 successes out of 40 trials, and we wanted 0.95. And that gives us from 0.7% up to 19.3%, which is exactly what we got. And again, that means if we were to have repeated this process 100 times, 95 of those times, we would have actually captured the mean between these two numbers. So we're 95% confident that the actual percentage of eggs that have double yolks is somewhere between 0.7 and 19.3%, which is not a terribly good estimate. It's pretty wide. We'll look at next time how to get that to be a little more narrow. I will see you next time.